Başlayabiliriz Özlem Hanım.
Tamam. Duyabiliyor musunuz beni? Duyabiliyor musunuz? Değerli katılımcılarımız, hoş geldiniz. Bugün TÜYAK tarafından düzenlenen internet seminerlerinin 9.sunu gerçekleştireceğiz. İnternet seminerimizin bugünkü konuşmacısı Sayın Rick Jeffries ve sunum konusu ise video görüntü algılama sistemi olacak. Video görüntü işleme teknolojileri günümüzde birçok alanda yaygın olarak kullanılmaktadır. Bu teknolojiler ile duman ve alevi de algılamak mümkün. Video görüntüleme teknolojileriyle yangını erken algılamada çok başarılı sonuçlar ortaya koyulmaktadır. Amacımız bu özel konu hakkında sizi bugün bilgilendirmek. Yangın algılama sistemleri en zorlu testlerden geçen sistemler olduğundan standartizasyon ve sertifikasyon süreçleri çok uzun sürüyor. Programımıza göre sunumumuz yaklaşık 45 dakika sürecek ve sonrasında da yaklaşık 30 dakikalık soru-cevap bölümü olacak. Sorularınızı buradan veya YouTube kanalı üzerinden sorabilirsiniz. Bugünkü seminerimizde ilk kez çeviri kanalı olacak. Bu kanalda dil seçimi yapmak için Zoom alt ekranında çeviri butonu göreceksiniz. İngilizce ve Türkçe olarak seçim yapabiliyorsunuz. Arka plandaki orijinal dili daha kısık sesle duyabilirsiniz veya sessiz mute seçeneğinden arka plan sesini tamamen susturabilirsiniz. Kendisine sözü bırakmadan önce Rick'i kısaca sizlere tanıtmak istiyorum. Rick seminere şu an Amerika'dan katılıyor. Houston, Texas'ta yaşamaktadır. Kara ve denizde özel tehlike yangından koruma alanlarında teknik hizmetler, satış ve iş geliştirmede 26 yılı aşkın deneyime sahiptir. Şu anda VAKFI firmasında özel algılama ürünleri için iş geliştirme direktörüdür. Rick, yangın alarm sistemleri ve özel tehlikeleri söndürme sistemlerinde NICET seviye 3 sertifikasına sahiptir. Teksas eyaletinde yangın alarm sistemleri ve söndürme sistemleri için planlayıcı lisansları bulunmaktadır. NFPA'den CFPA sertifikasına sahiptir. Maryland Üniversitesi'nde eğitim görmüş ve enstitüde risk yönetimi eğitimi almıştır. Halen video görüntü algılama uygulama standardı komitesi olan ISO TC21 SC3 WG24 komitesinde yer almaktadır. Şimdi sözü video görüntü algılama sunumu için Rick Jeffries'e bırakıyorum. Teşekkürler.
Thank you. Good afternoon, and thanks to everyone for joining us to discuss fire detection with video analytics. I've been with this technology specifically for about 11 years. It started out with Axon X Corporation with the Signifier product. FIKE purchased Axon X, and we've rebranded the product to FIKE Video Analytics. So we'll be talking about video analytics. I'll be showing you a lot of videos. So we'll talk about the technology. The analytics embedded in the camera itself, and we have server-based analytics originating from a computer software. So we detect smoke and oil mist using the same algorithm because smoke and oil mist look similar. We detect flame. We also detect the reflection of flame. So we'll talk about how we apply the technology, what we look for in an application to determine if the application is correct for the technology. Then we'll evaluate the hazard as to what we're looking for, a flame, smoke, and how we'll aim the camera to assure that we're detecting the smoke that's rising from a fire. We'll also talk about approvals that the system has and commissioning the system. So the video analytics is commonly used on marine vessels. This is from a cruise ship engine room. You can see in the upper right hand with the blue circle, that's oil mist. So the engine had an oil mist leak. The mist was a gas that expelled into the air. This is very explosive because it's atomized fuel. In the upper left-hand corner, you can see that the analytics detected a flame. So you see the red rectangle or square that indicates that it's detecting a flame. So this is a very hazardous situation on board a ship. We have both oil mist in the air that's very explosive, and we have an open flame. So our video analytics detected the oil mist first. There was an alarm sent to the engine control room where this live video was available for the operators to quickly react to the incident. They activated a local application water mist system that knocked down the fumes or the oil mist. And one of the operators went up with a fire extinguisher and put out the fire. So they had very fast notification of the event. So I will be talking about and showing you areas where we're installing. We have installed the system and show you various applications where the system is being used in actual videos. So this is an airport in Abu Dhabi. So we're protecting the terminal area. This system is installed and working well. Below left is designed, and you can see quarter circles laid out in gray. Those are the field of view of the cameras themselves. This is an airport in Qatar. We have 600 cameras in one building. This is an approved installation monitoring for smoke and flame in catering operations and the office areas as well. In New York City, we have a high-rise complex called Hudson Yards. It's a 13-building high-rise complex. We have FIKE video analytics or video analytics cameras in the first two buildings, and that's about 650 cameras, and these are all in high ceiling, large volume mechanical equipment rooms. So we're starting to design the third building that's coming up next. So we protect a lot of critical products, applications. So this is the James Webb Telescope. This is here in Houston at the Johnson Space Center. The arrows are pointing at the two FIKE cameras or video analytics cameras. We were looking for early smoke and flame detection in this application. On the left, you can see other areas that we're protecting. The bottom is a building where the SpaceX refurbishes their rockets. The Atlanta airport has a tunnel system underneath the airport. We have 107 cameras monitoring underneath the airport in these electrical tunnels, as well as their boiler building. So video analytics in tunnels works very well. With video analytics, we're monitoring a reference background, and we like to have, and we're using changes in light level to monitor for smoke or flame. So tunnels are very good applications because it's a very stable environment. No people moving around, no windows, and we can see a great distance with in these applications. So about a third of our business is marine related, involving the first video that I showed you. So all of the ships in this picture have our analytics system in the engine room, monitoring for oil mist, smoke, flame, and reflected flame. So this is Norwegian Cruise Lines, Carnival, Disney, and then Royal Caribbean Cruise Lines. So what they do is they install off-the-shelf on-VIF cameras, standard IP cameras. They have servers with video analytics, monitoring the video from the cameras for any signs of oil mist or smoke. So this is the UL test center. You can see the engineer lit the smoke emitter. As the smoke rises, the video analytics detects the smoke and puts a blue outline around the smoke. What that means is the system is in alarm for smoke. You can see the word smoke at the bottom of the screen. That means that the relays on the back of the camera have activated and sent a signal to the fire alarm panel. Now, video analytics detection area is the entire field of view of the camera. So with other types of smoke detection systems, the smoke has to physically interact with the detector. In this case, if the camera can see the smoke, it can detect it. So you can also see that the smoke is staying low. The smoke is not rising to the ceiling. That means there's a clear sign of stratification. Other technologies that may be installed at the ceiling may never see this smoke because the smoke in this case is staying low. It could be either the fire doesn't have enough energy for the smoke to rise, or there may be a thermal layer holding the smoke down. In any case, other detectors that are required to be mounted at the ceiling may never detect this smoke, but video analytics easily can see it. So why do we use video analytics? There are a lot of benefits in using video image detection. So as I just mentioned, there's no contact with the detector. The detector can see the entire room. So it's early smoke detection because the video analytics is monitoring, can see the floor or the process and detect the smoke before it rises and reaches the ceiling where other detectors might be installed. We can also detect reflected flame. I'll show you that. With video analytics, we're detecting in very large open spaces. That's one of the better applications for video analytics is high ceilings and large volume spaces. So because of the large area that video analytics can cover, you have fewer devices and a lower installation cost. So with video analytics, we're using video. That video is recorded on a server or a network video recorder. So it's recording all the time and tracking events. So when there is an event, you can go back and look at the recorded video and determine the cause of the event. So you can also use off-the-shelf cameras or listed and approved cameras. The maintenance for this system is very simple. It's all performed through a software routine. When you perform annual maintenance, you do not need to simulate smoke or flame. The cameras can be mounted into classified area enclosures, which allows them to be installed in classified areas, explosion-proof areas. So there's a wide variety of applications. So warehouses, large spaces, electrical equipment rooms, turbine decks for flame and smoke. Obviously, I showed you the marine and offshore mechanical equipment rooms, airports, cultural facilities with high ceilings, waste plants in some areas. Indoor parking garages work very well for the application. So we're using video analytics. Video analytics is used in many applications. The picture in the upper right-hand corner is a video analytics camera monitoring a process to assure that the lids or the caps are on the product. Bottom right, that would be a Xbox game. So you can see the video analytics monitors your body's movement. Security systems obviously use video analytics. The lower left picture is called heat mapping. So video analytics monitors video from retail cameras and looking for areas of high traffic flow, or what they call dwell time, how long people stand in front of a display. So that's highlighted in red. So all of these applications of video analytics are very similar in the way that they're using color and light across a video image, process that information for the output that we're looking for. Smoke detection is very similar. So we've trained our analytics through thousands of videos of fires. We're monitoring 640 by 480 pixels at 15 frames per second, analyzing the image for oil mist, smoke, flame, and reflected flame. So for every project, we work with engineers, our distributors, end users in evaluating the application before a project is awarded. So if you have any applications, please contact a video analytics distributor. You can contact us direct. We'll discuss the application first to determine if it is correct for this technology. If it is, support is provided for design, quantity of cameras. When the project is installed, the factory should support in configuring the devices. And it's very simple discussion at the beginning, and when the system is set up, it's a very simple evaluation and support with configuring the system. So we're monitoring. So this is smoke detection. On the left-hand side, you can see that the way that video analytics monitors for smoke, the analytics is looking for an organized group of pixels having a light level change, moving in an organized pattern consistent with smoke movement. The analytics have been trained to see that. On the right picture, the blue represents the pixels that have been affected, the newly affected pixels, the pixels that have been affected the shortest amount of time, they're farthest away from the smoke. The orange represents the pixels that are closer to the fire that have been affected the longest. So the way that we're tracking movement of smoke is tracking the amount of time that the pixels are affected. So this applies to both oil mist and smoke detection because they look very similar. This is an example of a smoke event. Down under the turbine, some oil was caught on fire or heated up. The smoke rises and is detected an alarm with the video analytics. And it's all represented with the blue outline. This is oil being burned off of an engine. So generator rooms are a very good application. Engine rooms on ships are a very good application for the technology. This is the high-rise mechanical equipment rooms. So on the right is a smoke test for the fire officials. You can see down at the bottom the gray outline. That means the analytics is tracking, but you can see the blue means that there's an alarm, plus the smoke is word at the bottom. What we do is we create alarm zones within the field of view of the detector. Those alarm zones are represented in the small pictures. You can see the rectangular white rectangles. Those are alarm zones. So the system tracks smoke everywhere in the field of view. When the smoke reaches the alarm zone, the system goes into alarm. The reason that we do that is to avoid false alarms from people and objects moving in the image. This is an example of oil mist. This is oil mist being released from an injector from a large engine. So you can see that the oil mist is clearly indicated with the blue outline, just like smoke. So this is an example of flame detection. The way that we detect flame is we're looking for slow changing brightness and flicker from a flame. The flame is represented by the detection is represented by a red box, and you can see the word flame on the bottom of the screen. This is an example of reflected flame. Our term is offsite at the bottom of the screen, and it's represented by purple dots. So the flame does not need to be visible directly for the video analytics to detect this event. They can detect the reflected flame based on the flicker off of the walls and ceiling and floor. So in our case, we have two lenses. We have an 8mm lens, which is represented in green. That's for, we would use those in tunnels and narrow areas. We also have a 2.8mm or 82-degree field of view lens. That's for large areas. The cameras are connected easily to a fire alarm panel. So any fire alarm panel can be used. There's 24 volts DC powering the cameras. And then you have monitor modules monitoring relays on the back of the cameras by the fire alarm panel. Since there's video, the video runs down through Ethernet, through an Ethernet switch to an NVR, where the video is recorded. The live video and display is through a computer screen. So this system would be an approved system. So we have UL and factory mutual approvals for these devices. There's also an ISO approval that's coming out soon. So this would be approved cameras. So very similar to any other installation as far as 24 volts DC to the detector and monitoring alarm and trouble contacts on the detectors. So the alarms that are received are from flame, reflected flame, smoke, which is also used for oil mist, and motion detection is also enabled on the detectors. So there you can get troubles from an image change. If you have no contrast, if the lights go out or the camera's looking at the floor or a wall, it'll go into trouble. If the camera is disconnected from the NVR or the fire alarm panel, if the lens is dirty or out of focus, system failure of the camera or loss of power. Those will all result in trouble conditions. Now, depending on the environment where the cameras are located, we can put the cameras in enclosures. So we have a glass or plastic that the camera looks through. And this is an explosion-proof enclosure. So we typically install our cameras in enclosures like this to protect the camera, to keep them clean, and to protect the wiring that's connected. So another type of system is a server-based system. So there are two types of systems available on the market. One would be a listed system where you have a camera with the analytics embedded on the edge or on the camera itself. And that camera is approved by a approval body, UL, FM, ISO, BDS. Another system is where the analytics are server-based. So you have a computer or a server with the analytics software, and that's monitoring video from a camera. So most systems use cameras or monitors cameras that are ONVIF compliant. ONVIF is a global communication standard for IP cameras. It allows a standard so that the server software and the camera can communicate. These are some companies that have ONVIF cameras, but most IP cameras on the market are ONVIF compliant. You can run an analog camera through an ONVIF encoder to do the same thing. This is another example of an engine room oil mist event. There was a large amount of oil mist released into the engine, made contact with the hot engine, and is released out the top of the engine. So the video analytics is analyzing the image and in alarm for oil mist. So this is really not smoke. This is atomized fuel. Very dangerous situation. So for video analytics, server-based systems, you have existing off-the-shelf, maybe security cameras installed. Those security cameras are monitored by a standard server. Video is displayed on large screen TVs or a computer. You would have an interface computer that's running the video management software. So if you'd like to add video analytics to this existing installation, we add a video management or video analytics server. The video analytics server is programmed to monitor the specific cameras. It's just connected through the Ethernet. The video management software for the video analytics is installed on a computer. And we also install a relay that's powered over Ethernet on this network. So the video analytics server monitors the video from the cameras. When the video analytics sees oil mist or smoke or flame, it sends a signal to the relay. The relay will operate and send an alarm to the monitoring location. The video management software for the video analytics system is usually running minimized in the background. When there's an event, that software will pop up on one of the displays, and you'll see the video analytics overlay representing the detection. So when we're designing a system, we have a layout of a building. We have the dimensions of the area. And then we usually start in the corners to follow the walls. So we have the lens that I showed you earlier, 82 degrees field of view. It's very close to a 90. So we'll start in the corner and follow the 90 degree of the walls. We'll go out to about 30 meters and have our coverage area for one detector. So what we end up doing is we drop quarter circles on the drawing to indicate the areas of coverage and the camera locations. As you can see, there's a narrow area over in the upper left corner where a narrow lens is used. So once we have this design, then we know the quantity of cameras, and we can determine how the size of the NVR. Okay, so FM Global is an approving agency, so they approve video analytics. UL is another American approval agency. And then ISO has a standard that will be released soon, which will also be used to test cameras. The ISO will also give you guidance on installation. So there are various standards, UL 268B, FM. So we've done some comparative testing with video analytics compared to aspirating fire detectors, spot, smoke and heat, beam detectors, and linear detectors. So in this case, the detectors were mounted above the fire. The ceiling was about 6 meters high. The video analytics detected 88% of the time faster than the other technologies. So the aspiration detection detected all of the fires, but it was first to activate only 6% of the time. The video analytics detected all the fires and was first 88% of the time. The times that the video analytics were detected second was when there was an obstruction in the field of view and the smoke could not be detected until it was very high. So video analytics detected faster than the other technologies. The reason being, video analytics can see the floor and is detecting from the floor to the ceiling in most cases, and can see the smoke rising from where it's originating. So, video analytics inherently is monitoring video, analyzing video to detect smoke and oil mist. So we need some light to be able to see the smoke or the oil mist. Flame and reflected flame have their own light, create their own light. So they can be detected in complete darkness, but video analytics needs some light to see the smoke or oil mist. So any hazard where you've got video analytics installed needs to have stable lighting and uniform lighting throughout the space. So in our case, we need 1 foot candle or 10 lux of light. So we use alarm zones to monitor for smoke or oil mist. And this allows us to avoid false alarms and target areas specifically for smoke. So the alarm zone is a virtual zone that's programmed into the system. It extends from the camera to as far as the camera can see. So we have a smoke alarm zone here. The smoke would start down lower. It would rise. It would be detected and analyzed by the camera or the analytics. When the smoke reaches the zone, the system goes into alarm. So one way that we can use zones is to avoid false alarms from things moving in the field of view. So we have blue zones represented here for smoke alarm. So if there's, say this pallet with paper goes into alarm or starts to smoke, the smoke would rise. It would be tracked by the analytics. When the smoke reaches the alarm zone, the system goes into alarm immediately because it's been tracking the smoke. Now, these red boxes are flame blocking zones. So we're telling the software, if you see flame in these red boxes, do not go into alarm, because that's normally in the process to have a flame in these areas. So if there's a flame in this, the paper on the pallet on the floor, a flame starts there, the flame will be immediately recognized and alarm in the system because we're only blocking in the red areas. So there's an infinite amount of applications for the alarm zones. It just depends on what the field of view and what the activity in the space is as to how we set up the alarm zones. So this is the Johnson Space Center again. This is the Orion spacecraft. We set off a smoke emitter behind the equipment. As the smoke rises, it's tracked. And as soon as the smoke touches the alarm zones, the system goes into alarm. So considerations, we'll look at what in the space is going to catch fire. Where do we have issues with potential false alarms? So with video analytics, we need to be concerned about people or objects moving close to the camera or in front of the camera. So when we look at an area, we'll determine where we're going to put our alarm zones, which is usually above the equipment and above activity and people. We'll also look at any lighting. So we do not use video analytics outdoors because you can't control the sunlight, the shadow. It's very dark at nighttime, obviously outside. So we only use video analytics indoors. We recommend that they're used where there are no windows. So if there are a lot of windows in a space, we would likely suggest another technology because we need with video analytics, we need a stable background. You know, the video analytics needs a stable reference background of colors, contrasts, that we can monitor and then look for changes in that field of view and recognize those changes as really smoke, oil mist, flame, or reflected flame. So video management software is always included with video analytics systems. So you can monitor the video live and you can see an indication of an event. So in our case, you'd have a red flashing outline around the image, and then blue for smoke or red for the alarm. You can also have a plan view of the facility, indicate where the cameras are, and then they will flash red when there's an alarm. Since the NVR or the server is recording all the time, you have a timeline. So the timeline in the top area is a compressed view of events. Blue is smoke, red is flame, and then green is motion. The area down below represents 30 minutes of time. So this vertical red line over on the right-hand side is on top of 3 motion events. You can click on these motion events and bring up video from that specific event. You can download the video. You can grab this vertical red line and move it over to maybe here where these 3, with the 3 cameras detected smoke. And those will be expanded down here where we can look at the event video and download the video as well. So when we commission the system, the cameras are installed. An audit report is generated after the zones and the settings are configured. The audit report looks like this. You'll have a picture of the camera view, you have all the zones, and then you have the settings. So you'll have a report of all the cameras with their zones and settings. We'll save that. We can test using different methods to create a fire. You can even use a video of a flame and hold it in front of the detector if you like. There are smoke emitters that will generate smoke to be detected by the fire or by the video analytics. You can use fog machines. Canned smoke that is used for smoke detectors, spot smoke detectors, is not used because it doesn't look like smoke. So we commission the system, test the system. The audit report is generated. The audit report also creates a sketch of what the camera is looking at. So we have a record of what the camera was looking at when it's installed. And we save that audit report with the sketch on the NVR. So this is actually 2 engines here and a little walkway. So the way that we annually test the system is we run a verification sequence with the software. So it's very simple. We'll go into the video management software. We'll run a verification routine using the audit report that was generated at commissioning. The system will compare that with current conditions and create a verification report. If the cameras are all looking in the same direction, looking at the same equipment, if the zones are all the same, if all the settings are the same, the software will generate a pass report and the system will have been tested in the first phase. The second phase of the testing is in the software. We can force alarms to the cameras. Those relays on the cameras will change state and send a signal to the fire alarm panel. And that confirms that the relays are operating, the modules from the fire alarm panel are working, and there's a direct communication between the relays on the camera to the fire alarm panel. So that's the testing. We run the verification routine, and then we force alarms to the camera to confirm communication. So we have the acceptance, which we run the audit report, and then inspection, we run the verification routine and force alarms to the fire alarm panel. So there's a new product on the market. FM Global created a new standard for Firewatch. The new standard for Firewatch is used instead of personnel monitoring for a fire during welding or hot work operations. So rather than having a person standing by watching for a fire, FM Global has developed a standard for a Firewatch unit. What that Firewatch unit does, it monitors the area using flame detectors that can be used with video analytics. So this is a flame detector, but it has an IP on VIF camera with HD video. So the flame detectors are looking for a flame with the flame detection, and a computer inside this box with video analytics is monitoring the video from this camera for smoke, reflected flame, if needed. Primarily, it's looking for smoke indoors after the hot work is completed. So this is something new on the market that you'll see soon. So that is the presentation. If there are any questions, we'd be glad to answer or discuss your questions with you.
Thank you very much, Rick.
I see one question. Do these cameras use standard cameras? If not, what is the wavelength? So there are two systems. There is a camera with analytics on the camera itself or on the edge. So that would be a standard IP camera. Or I'm sorry, that is not a standard. So in our case with FIKE, we make our own camera. We have the analytics on the camera itself. There are other cameras, video analytics companies that take an off-the-shelf camera and install their software on the camera and use the video analytics on the camera in that case. There is a third system where you have the video analytics in a server. Where you have a video analytics in a server, and the video analytics is monitoring the video from the off-the-shelf camera. So you can use a camera that's made by a video analytics company, a camera that's off the shelf where you load the software onto the camera itself, or you have server-based analytics that are monitoring video from any IP camera.
Rick,
Yes.
we have a question from YouTube from Faik Semruh. He's asking that which is the most successful standard in the world about this video analytics?
What's the most successful standard? Well, I think that the most prevalent standard is we have UL.
Yes.
UL 268B, and then we have Factory Mutual Standard 3232, and we have the new ISO standard that I showed that will be released probably by the second quarter of next year. So some of our customers look for UL, some look for FM, and other. So those are primarily countries that are looking at the National Fire Protection Association codes, but Europe, Asia will be looking at the new ISO code.
Is there a standard, EN standard preparation in Europe now?
No, there's not. Unfortunately, EN 54 does not include video analytics. That is why the ISO standard was developed.
So this is a secondary detection system?
Not necessarily. Most of our installations are primary detection.
In US?
Yes. Well, where in the United States, Latin America, the Middle East, where NFPA is accepted. There are video analytics installed in Europe, and it's up to the authority having jurisdiction as to whether they accept the video analytics as primary detection or not.
Okay.
So it's all down to the authorities.
Okay, thank you, Rick. I'm asking for the attendees for their questions. Sorularınızı kanal üzerinden veya YouTube üzerinden alabiliriz. Sorusu olan varsa. There is a question, Rick. Rick, there is a question. Can you hear me?
Okay, yes.
I am changing the channel. There is a question from Muratcan Sevim. He's asking that video detection is video detection better than water-based extinguishing systems according to you? In the future it will be used commonly?
Video analytics is a detection technology. So video analytics will tell you if there's a fire, detect it early. Water mist system are usually activated. They will suppress a fire. So we use video analytics to detect a fire very early. But we're talking about two different things with water mist.
Yes.
In some applications, video analytics is used because it has early detection, and a sprinkler system can be avoided because the video analytics can detect very fast. So
okay, they are different things.
They're different things, but we do have some installations where a sprinkler system may be very expensive. Maybe it needs to be installed in an existing application where the authorities agree that if you have early detection from video analytics, that'll allow sufficient time for the fire department to react and put out the fire, where you may not need a suppression system.
Okay, thanks. We have another question. from YouTube. Barış Topal is asking, can we use this system for separation as a cross zone, smoke plus flame with individual signals?
Yes, we do. We do not use the individual signals from the same camera, but where we have multiple cameras in a space, we certainly can cross-zone the signals from the different cameras in the fire alarm panel to initiate release of a suppression system.
Okay. Is there any other question? Başka sorusu olan var mı? There is no other question. I will ask a question, Rick.
Okay.
Is it possible to detect the fires, outdoor fires, with this
Outdoor
cameras? Yes.
Yes, you can. We do not use our video analytics outdoors because of issues with, say you have a puddle of water and the sun is out and it's still raining. So you have a flicker and an image that looks very similar to a fire that's created by natural event that can fool the analytics. So we do not use video analytics outdoors. Our system is FM approved to detect flame outdoors. So if a customer would like to use the video analytics outdoors, we look at the application and decide with the customer if it's appropriate technology in that application. So yes, it's approved, but we're very careful about using video analytics outdoors. Certainly not for smoke, because you need light to see smoke. But for flame, it is possible, yes.
Yes, we don't like dark, I think. We need an illumination level for this.
For smoke.
Cameras.
For smoke and
For
oil
smoke.
mist, yeah, and we need light. Flame, reflected flame, create their own light, yes.
Is the color of the smoke important?
No, not for our technology. There are video analytics companies that base on color, but for the most part, we're just looking at a change in light level across the pixels, moving in an organized pattern. So the color of the smoke is not important. We're looking at the contrast and the light level across the image.
Okay. I will ask for other questions. Başka sorusu olan varsa ben Rick'e yönlendirebilirim. Şu anda soru görmüyorum. YouTube üzerinden bir sorumuz var. We have a question, Rick, from Hatice Zehra Tonyalı is asking, can we use this camera on closed turbine enclosure to detect flame and heat?
Yes, the system is commonly used in turbine to detect flame. Video analytics does not detect temperature, so it will not detect the heat, but it will detect the flame, the oil mist potentially, and smoke. But in turbine enclosures, we need to be very careful about the airflow, number one. The explosion rating of the hazard and the temperature in a turbine enclosure. So in the last slide, I showed you the flame detectors with the Firewatch. So what we do is we install the VAKFI flame detector in the turbine enclosure that has the video camera. So we monitor for flame with the triple IR, or the multi-spectrum flame detector. The video is processed outside of the turbine, where we can monitor for oil mist and smoke. So you're getting oil mist, smoke, and flame detection all through one device.
Okay, thank you. We have another question from Muratcan Sevim. He's asking, is there any country where this video image detection is mandatory? In which countries it is a must?
I would say that there are no countries that require video analytics. It just depends on the application and the type of detection that's required based on the application. I would say that in most countries that accept video analytics, if there's a high ceiling and a large volume space, that video analytics is primarily used. So I hope I've answered that question. The answer is no. There is no country that requires video analytics.
Okay Rick. Hiçbir ülkede bu sistemin zorunlu olduğu hiçbir ülke yok diyor Rick. Şimdi başka soru var mı? Başka soru varsa onları alalım.
Sanırım yok Özlem Hanım.
Şu anda evet sorularımız bitti. Thank you very much Rick. It was a very good presentation. Kendisine, Rick'e bu güzel sunumu için çok teşekkür ediyoruz. Hepimiz için çok faydalı bir sunum oldu. Bu seminerin düzenlenmesine katkı koyan herkese, çevirmenlerimize, sponsorlarımıza çok teşekkür ederiz. Özellikle siz değerli katılımcılarımıza çok teşekkür ediyoruz. Bundan sonraki TÜYAK etkinliklerinde sizleri tekrar aramızda görmek üzere. İyi akşamlar diliyorum herkese. Burada son bir şey söyleyeyim. Son 2 webinarımızı da paylaşayım ben sizlerle. 15 Aralık 2020 tarihinde yangın kompartımanı, otomatik yangın ve duman perdeleri uygulamaları konulu internet seminerimiz olacak. 24 Aralık 2020 tarihinde de yangın güvenliği sorunları, sorular, cevaplar başlıklı bir internet seminerimiz olacak. Herkese çok teşekkür ediyorum. İyi akşamlar diliyorum.
Thank you.